Okay. All right. So last time we started talking about normal distributions and how we can find specific parts of our data, or specific locations of our data within those normal distributions. So once again, when I say normal distribution, what I mean is that if we plot our frequencies for all of our data points, they might come out looking something like this, where we have this nice even curve. Everything is symmetrical. So these areas where the curve is very short would be where we have a data point that doesn't have a whole lot of frequency, so maybe it only happens once or twice. So that means that up here, where we have our peak, that is the data point that happens the most. It has the most frequency. And of course, we would call that the mode. It's the data point that happens the most. Now, since this is normally distributed, so a nice symmetrical curve, that mode happens in the middle. Well, this also splits the data into two equal parts. So 50% of our data is on this side and 50% of our data is on this side. Which means that since it's splitting it equally, this is the exact middle. Well, the exact middle of our data would be the median. And finally, if the mode and median are right there smack dab in the middle and the same, then this is also our mean, our average. Then we also said that if we know the standard deviation of this data, well, most of our data is going to occur within one standard deviation of the mean. So one standard deviation on this side, one standard deviation on this side. This is where most of our data is going to occur. Now that's great. It's nice to know where most of the data is. However, what if we want to know a specific location? What if instead of knowing where most of our data is, we want to know what data falls, well, maybe below a certain point? In other words, how much of our data is represented by this area? Okay, well, to figure that out, we need to know a few things. First of all, we need to know what this point right here is. So where does this area stop? This is an x value. Of course, an x value is just any random data point from our data. So in this case, let's say it's 50. Then that means that this area that we're trying to find is all the x values that are less than or equal to 50. Making sense so far? Okay. Okay, so we need to know a few more things besides just that x value. We also need to know the mean. So the mean in this case, let's say, is 70. Then we also need to know the standard deviation. And for this one, we'll say it is 10. So to find how much of our data is represented by this area here, we need to have a z-score. And a z-score is calculated by taking the x value that we're looking at and subtracting the mean from that, and then dividing it by the standard deviation. Okay. Now, why are we doing this? Well, the reason is because the first thing this does is figure out how far this point is from the mean. So, how far off from here is it? Then we divide by the standard deviation because the standard deviation tells us what this curve looks like overall. Not all of these curves are going to look exactly like this one, though they could still be normally distributed. So we could have a curve that is really gentle, kind of shallow, like that, or we could have a curve that is really extreme. Now, these are both normal distributions. They're both symmetrical, and their means occur in the center, just like this one. So this standard deviation tells us what these curves are like. Okay, so what kind of curve are we dealing with? So first we find the distance that this is from the center, and then we relate it to what the curve overall looks like, so that we can get an image, kind of a picture in numbers of what is at this point. And again, that's a z-score. A z-score tells us what this point is like in the curve, where it really is in the curve, and how it relates to the curve. Then once we get that z-score, we can take it and look at the tables that it gave us today and find a probability. Now that probability really tells us how much of our data is in there. Remember that probability is a part out of the whole. So when we look up a probability on here, it's going to be telling us the part. What is this part out of the whole? So we need to plug in our numbers into our formula to get that z-score so that we can get our probability. Okay, so z equals x. The x that we're looking at is 50 minus the mean, mu, which is in this case 70, and then divided by sigma, the standard deviation, which again in this case is 10. And then it's just a matter of doing the simple math that's right here. So first thing we need to do is figure out the top of this fraction. So 50 minus 70 is going to give us what? -50 minus 70, -20, great. Okay, and it's still being divided by 10, so -20 divided by 10, what's that? -2. Okay, so there's our z-score. Again, this is what kind of gives us a picture in numbers of where this x value is on what kind of curve. Then we can take this z-score, the one that we just got, and look it up on our table. Now the first page that is in this packet that I gave you is for positive z-scores. These are things that are above the mean. So if we have an x value that is above our mean, it'll give us a positive z-score. This will be the table that we want. However, our x value is below the mean, and because of that, it gave us a negative z-score. So we need to flip to the next page instead, and this is the table for all of our negative values, all of our negative z-scores. So we need to look up the digits of our z-score. The first digits are over here. So we scroll down until we find -2. There it is. And then nothing comes after that. There's no decimals or anything. I mean, in theory, you could make this -2.0, right? So the next part would be, well, there's nothing, so 0. So scroll down until we match these up. So they intersect right there at, let's see, 0.02275. So that's our probability. Okay? So what this tells us is that if we were to choose a data point at random from our entire set of data, that there is a probability of 0.02275 that it's going to fall in this area. Another way to look at this is to make this into a percent. So take this decimal, move it twice to the right to get a percent. That's 2.275%. And this tells us that 2.275% of our data is in this area. Okay? So maybe the data that we're looking at here is the ages of people in a retirement home. Okay, so the average age of a person in the retirement home is 70 and a standard deviation of 10 years. Okay, so if we calculate all this, what we've just found for this data is that from here to here, so from whatever our lowest data point is to 50, in other words, 2.275% of our people in the retirement home are below 50. Does that make sense? Okay. Now, what if we want to know the amount of people in this retirement home that are above the age of 50? Well, what we just calculated is below the age of 50, so we need to go the opposite direction. However, if we look at our z-score tables, neither of these pages calculates above. They both go below. So how are we going to find this? Well, again, we talked about this on Wednesday. We said that the entire curve, the entire set of data as a whole, would represent the probability of 1. Okay? So, if this entire thing is 1, but this part right here is 0.02275, what we could do is we could take this part off, so literally subtract it from the entire thing, and that will give us the other part. Does that make sense? Okay. So again, if we want to know the amount of people, or the percent of people in this retirement home that are above the age of 50, then what we need to do is just take this part and get rid of it. So we only have the people that are above the age of 50. Again, the whole thing represents 1, a probability of 1. That's true for all curves. They will all have a total probability of 1. So what we do is we take 1 and subtract the probability that we found. So in this case, 0.02275. So let me just punch that into my calculator and see what I get. 1 minus 0.02275, and that gives me 0.97725. Okay, so what we just found now, again, is the amount of people that are above the age of 50, so this side of our curve. So this number right here is the probability that if we selected a person at random in this retirement home, this probability tells us that 97, almost 98% of those people are going to be over the age of 50. And of course, percent. Whoops. Okay. Does this make sense? Okay. Just one more time. If we want to find the percent below a particular point, that's pretty easy. Just plug in your numbers, get your z-score, look it up. If you want to find above, it's the same thing, but you got to add one more step, and that is to subtract it from 1 so that we can get the other side. Any questions? Okay. So again, this is what we talked about on Wednesday. We said that we can calculate below or above, and then I told us that, well, if we can calculate it above and below, what about calculating something like in between? Now, we actually have all of the tools necessary to find this. We just have to think a little bit about how we need to go about doing it. Okay, so let's think about what we know how to do. First of all, we know how to calculate below. Okay, so for instance, this one right here, this x value, whatever it is, I'm going to call it x1. If I were to find the z-score for this and then get the probability, that would give me this area right here. Okay, it'd be that area right there. Then this one right here, let's call it x2. This second point that would give me the probability of everything behind it. So this area and this area. But we want to get rid of not this, we just want to get rid of that and that. So we need this one to calculate not below, but above. We want to get rid of this part. Okay? So x1, we want to calculate this part below so that we can get rid of it. And then x2, we want to calculate this part above so we can get rid of it and just have this left for our answer, right? Okay, so let's try this out. let me make a graph here that we can work with. Again, mean is always going to be in the middle of that curve, the very highest point. And let's see, let's have a mean of 72. And our standard deviation will be 2. So let's get some x values in here. Let's say one of them is right here and one of them is right here. So we're going to find this area. Okay, so x1 is going to be 65, and x2 is 69. Ready? All right, let's try it. So again, we want to get rid of this part and this part. So for this x value, we can just calculate what's below it and then subtract it. So this one, we're going to have z equals, let's see, our x is 65. Then minus the mean, 72, find that distance between them, and then divide it by the standard deviation 2 to fit it to the curve. All right, well, let's figure out what that is. So 65 minus 72 is -7. Divide that by 2, and we get -3.5. So the z for this part, which I'm going to call this z1, is -3.5. Okay? Then this one, again, if we calculate below, it's going to cover stuff that we already know. Now, we'll show you a little bit of trick in just a minute here. But if we calculate this one below, it's going to cover stuff we already know. So we don't want that. We want to calculate this side. So first, we're going to calculate what this covers over here and then flip it to this side by subtracting it from 1. So this part is z, let's call it z2, equals 69 minus 72 divided by 2. So 69 divided by 72, whoops, 69 minus 72 divided by 2 is -1.5. So z2 equals -1.5. Again, this is not quite yet to this side, it's just calculating this. We need to find the probability for this and then flip it to this side by subtracting it from 1. So let's find our probabilities. Again, we need to look at our z-table to find the z-score on there and then get our probability from that. So let's look at them. Both of our z's are negative, so we're going to need to look at our negative z-table. And so let's see, -3.5, scroll down on the side, Okay, there's 3.5, and then, okay, nothing else comes after that, so we can just go to the 0 part. See where they cross. That crosses at 0.00023. Okay, so again, this is this part. And it's ready to go. We can go ahead and take it away. We don't need to process it anymore. This one, on the other hand, again, we want to eventually get it to flip to this side, so let's find its probability and flip it. So negative 1.5, again, scroll down the side here, and then nothing comes after that, so we can just use the 0 column, and that is 0.06681. Now again, what we just found there is the probability from this point back. We don't want that though, we want this point forward, so we need to flip this. So 1 minus P2, or in other words, 1 minus 0.06681 will give us the actual part that we need. So 1 minus 0.06681, that gives us 0.93319. All right, so what we have is that this part is 0.00023, and this part is 0.93319. So those are the parts that we can break off of the whole so that we only have this part left over. So let's go ahead and subtract these from 1 so we can get just this part. So 1 minus 0.00023 and then minus 0.93319 gives us that this part right here is 0.06658. So as a percent, that means that just over 6.5% of our data falls between these 2 points. Does that make sense? Okay. So that's one way of looking at it. Now here's another way, and this is actually just pointed out to me by someone today. Let's think about these two numbers. In fact, I would say that this is an easier way to do this. Okay, so this is like this one, P1. And then this one is P2. Whoops, sorry about that. let's think real quick. If I find P1 and I find P2, well, what happens if I just lop off this part that represents P1? What happens if I get rid of it? It's gone now. Well, I get that space in the middle that we were looking for. So the other way that we can think about this is to get your P1 and subtract it from your P2. And that will give you just the part that they don't overlap on. So this one right here. So just to check and make sure that that does indeed work, our P1 was 0.00023, and we need to subtract this from, let's see, 0.06681. Let's go ahead and subtract that and see what we get. So 0.06681 minus 0.00023 gives us 0.06658. Hey, that is the exact same number that we got from our other calculations. So this does work. So you can either think about it like this, where you're flipping this and then subtracting both of these sides to get just this part in the middle, or you can get your probabilities, your P1 and your P2, subtract P1 from your P2, and it'll just give you that part right there. So they both do basically the same thing. It's just different ways of looking at it. And whichever way you want to do it, fine by me, as long as you can get to the correct answer and you understand how you got there. So any questions? None? All right. So one more thing I want to show us before we go today, and it's going to be pretty quick. Let's say, again, we have a normal distribution. Mean in the middle. And instead of being given an x, what we are given is the probability. So let's say the probability here is 0.99224. So what we've been doing so far is we've been taking the x value, getting a z-score out of it to get a probability. Here we've got the opposite. We've got a probability, and we want to find the z-score to get the x, because we don't know what it is right now. So how do we do that? I'll tell you this right now. This is a question that you are going to see on HOX. HOX is going to give you this type of problem. However, you are not going to find a value for x. You're not going to get a number for x because you don't have the standard deviation and the mean. You need both of those things to find the x in this case. So what HOX is going to want you to do is find an equation for x. So let's see how that works. Again, we need to find the z-score that represents this probability, because we don't have a formula for probability, we have a formula for z-score. Again, that formula is z equals the x minus the mean over the standard deviation. So let's look and see if we can find a z-score that lines up with 0.99224. Well, this is above our mean, which makes sense. This is a pretty big probability, just over 99%. So we're going to need our positive z-table. And we're going to look through this thing and see if we can find a probability of 0.99224. So first, let's see if we can find some 0.99s. And okay, let's see some 99s, 9999, 99, 9998. Okay, so I need to go back down. And then let's find 0.99224. So this is 0.992, so we're on the right track. And the next one's 0.99224. So we've got it. So this one right here, let's find the first two digits. That's 2.4. And then the next digit is 2. So altogether, our z-score that matches up with this probability is 2.42. Does that make sense? Okay. So z equals 2.42. Now we can put this into here for our z. Now again, if we had our mean and standard deviation, we'd be able to find a value for x. But that's not what we're going to find here. We're going to get an equation for x. So what we need to do at this point is we need to get x by itself. We need to get this whole thing solved for x. So we need to eliminate the other things around here that are not x. Well, the first thing that I see is this fraction, and that's kind of getting in the way of me solving this thing easily. So let's get rid of that fraction first. So what's making the fraction is that we're dividing by the standard deviation. So let's do the opposite and multiply by the standard deviation. And that will cancel. Now, of course, whatever we do to one side, we need to do that to the other side as well. So we're going to multiply this side by standard deviation also. So that gives us 2.42 times standard deviation, or 2.42 sigma, equals x minus mu. Okay, now we want to get rid of this mu. So this is x minus mu right now. The opposite of minus mu would be plus mu. And again, do that to both sides. So that cancels. And on this side, we have 2.42 sigma plus mu equals x. And there's our equation. Once you get that x completely by itself, you're good to go. You've got your equation. Any questions? None? Okay. So that'll do it for today. Next week. First of all, remember that Wednesday of next week is a holiday. So no classes on Wednesday of next week. Also, expect a quiz next week. Now obviously it can't be on Wednesday, and it would be evil for me to give it on Monday, so it means quiz is going to be what day? Friday. Okay, so again, prepare for that quiz, but other than that, I will see you later. Have a good weekend.